So this question talks about compound interest, and it's telling us the percentage rate is 3%. Now, compound interest, we need to remember, is linked to exponential formulas. So it's of the format P equals, doesn't really matter, AB to the power X, where P is your value, A is your initial value. So this is value now, A is your initial value, B is the percentage multiplier, and X is the number of time periods, quite often the number of years, but you've got to be careful that you could be talking about a monthly interest rate, you could be talking about a monthly increase in bacteria or whatever percentage change it is. So this is a general formula for using for compound interest type questions. There are various forms of this equation, but it's always going to be the same kind of theory, that you've got some new value, it's always equal to the initial value times the percentage multiplier to the power of the number of time periods. So this one we've got 2 years and the value is, so we know that we've got £2,652.25p, and it's equal to the initial value. Well, it says he invested an initial amount, well we don't know what that is yet, so we'll just call it A. But we do know what the percentage multiplier is because it's a 3% increase, because interest is increasing. So the percentage multiplier is 1.03. Again, if you're not sure why, then remember that your original investment is always 100%. You've added the 3%, so you now have 103% of what you had at the end of each year, and as a decimal we divide that by 100 and we get 1.03. And they're telling us that this was for 2 years, so the power here will be 2. So to get our initial value then, we're going to have to divide, because we have to move this part across here to leave us with the initial value of what I've called A. So we're going to do £2,652.25p divided by 1.03 squared. Calculator paper, so calculator, so £2,652.25p divided by 1.03 squared. So 2,500. Now if we wanted to check that worked, then we could go and do the reverse. So we're doing this for 2 years. At the end of the first year it would have multiplied by 1.03, and whatever that value is, because it's a compound effect, we then multiply that by 1.03 again, and we should find that 2,500 times 1.03 times 1.03 gives us the £2,652.25p. So that's a way of checking that our answer actually worked. Okay, so that's the first part of the question sorted. Literally we're having to then look at the next part, and the next part says that it's going to invest for 5 years, and it's got a saver account where it pays 4% per annum at compound interest, and you've got an investment account which says you get 20% interest paid at the end of the 5 years. Okay, so sometimes that's the way things work. You can put money into something, commit to a particular time period, and they'll say you guarantee you get this percentage on your money you put in. This one's about the standard investment account. Which account is best? So, and you must show how you got your workings. Well, these kind of questions, best to split your page into half and give some headings. So this is the saver and this is the investment. So this one's a fairly straightforward one. It's 21% interest, so that means we must have times by 1.21 for a 20% increase. And this one's saying that it's 4% per annum compound interest. So each year we're multiplying by 1.04, but we're doing it for 5 years. So whatever our initial investment was, and it's the same for both, so I'll just call it I for initial investment. We'll be tied by 1.04 to the power of 5 in the saver account, because we get that 4% interest every year for 5 years. So if we look at 1.04 to the power of 5, that gives an answer of 1.2166, and this one has a multiplier of 1.21. Remember why? Initial investment was 100% plus the 21% extra, gave you 121%, but as a decimal multiplier you divide that by 100. So this one means increase of 21.66%. And it says which account is best, so we must say what the answer is. So saver account. So saver account is best as it gives 21.66%, which is greater than 21%. Okay, so this kind of question, we didn't actually need to know what the initial investment was because we're comparing the percentage change, and this one used the general idea of compound effects, which you do percentage multiplier to the power of the number of time periods. In this time it's 5 years, and this one told you you've got a straightforward 21% at the end of the investment period. So comparing those two, we can see this one was larger.